Hello, this will be a demonstration of Proposition 24 from Book 7 of Euclid's Elements, which says that if two numbers be prime to any number, their product is also prime to that same number. What we're given is two numbers a and b, and both of them will be prime to the same number c, and we're going to have the product of a and b, we're going to call that the number d. So a times b equals d. And what we want to prove is that the number c is also prime to the number d. First, this is not the case if they are not prime to one another, then they're going to have some common measure. We're going to call that common measure e. So the number e will measure both the number c and the number d. Now, because the number c is prime to the number a, we were given this right off the bat, and the number e measures the number c, we can then say by the previous proposition 7.23 that the number e is also prime to the number a. Next, we're going to set out a number f. And what's going to be true about the number f is that the unit g will measure the number f the same number of times that e measures d. We know that e measures d, so we're going to set out the number f such that the unit g measures it the same number of times that e measures d. Now, because the unit g measures the number f the same number of times that e measures d, we can then say by proposition 7.15 that the unit measures the third number the same number of times that the second measures the fourth. What that means for us here is that the unit g also measures the number e the same number of times that the number f measures the number d, which means just by definition of multiplication, that is definition 7.15, we can say that the number e times the number f equals the number d. But we were given that the number d is also the product of the numbers a and b. So we have two products which are equal to the same number, common notion 1, they're equal to one another, so that a times b equals e times f. And because this is the case, by proposition 7.19, which is just the converse of cross multiplication, we can then say that the number e is to the number a just as the number b is to the number f. But we know that the number e is co-prime with the number a. It is prime to the number a. We established that in the second step here. And because they're prime to one another, they are the least of those which have that ratio. That's proposition 7.21 that tells us that. And furthermore, we know by proposition 7.20 that the numbers which are the least of those which have the same ratio measure those which have the same ratio with them the same number of times. What that's going to mean for us here is that the number e measures the number b the same number of times that the number a measures the number f. Now, Euclid doesn't spell that whole thing out because it's not important. Not all of it is important. What matters for us is not that the number e measures the number b at the same number of times that the number a measures the number f. What matters is simply that the number e does measure the number b. We wanted to establish that, and we have. But we also know that the number e was made to measure the number c. So the number e is a common measure to both the number b and the number c. And because it is a common measure, the number b and the number c, they have a common measure, which means they are not co-prime to one another. But this is contrary to the given. We were given that the number b is prime to the number c. And so what we find is that the number b is at once prime to the number c and also not prime to the number c. This is manifestly absurd. And so we can say that there is no common measure between the number c and the number d, which means, of course, that they are prime to one another, which is precisely what we set out to prove, which means we are done with the proposition. Therefore, etc. q, e, d. Particular example of what that's going to look like for us here. We can say that 3 and 5, they are both prime to 8. So, what we can say about this proposition 7.24 is that the product of 3 and 5, which is 15, is also prime to 8. And this is obviously true, so we see that the proposition holds. That's all I've got to say about this one, so I'll end the video here and move on to proposition 7.25.